Hello and welcome back to another lesson where we are converting a high-res sculpt of a character into a low-poly animatable model with maps, and we are doing it for a very particular game project. You will find the link to the project in the description of this video. Here we have a low-poly mesh which we made in the previous lesson, and I need to do some additional touch-ups here, so we'll take it to 3ds Max. Here we are inside 3ds Max. The same model looks a little different because the shading algorithm tends to be different in every single application. A couple of words I want to say about the topology. As you can see, the topology is not very clean. The edges, it's sort of ragged a little bit. But that is okay, like I said in one of the previous lessons. We don't have to be too meticulous with our topology, because what matters is the functionality, and this particular model will not be deformed much during animation. Therefore, we can get away with not investing extra time into making it super clean, and it is not super heavy either. If I count polygons, it's just 486 polygons. That is not much. But what does matter for any model, if you are going to bake any maps for any low poly model, what matters is the topology of some crucial areas. And in a second I will point out the potentially problematic areas of the model and the ways we can fix those areas to make sure that maps, especially normal map, which is the trickiest probably map to bake because it contains a lot of information, and if there are any defects in that map, it will be very visible on the low poly model. So what can be the potential problems with this model? The most common thing with any low poly mesh, the most common problem is areas like this, pointy areas, because normal map baking algorithms, they really hate narrow angles, and here you can see it is a very narrow angle and the pointy part of the topology of the model. So let me just open a drawing application so I can explain visually how we can fix this. Pay close attention. So let's say we have this narrow area. The red will be a cross section of the high-res model, and the model converges to a point. The initial inclination might be to just retopologize it like this. The blue is, let's say, a low poly model constructed on top of the high-res, to just copy the flow of the surface. But that would be incorrect because, again, narrow angles, they don't really bake very well. Or they can bake okay, but then there will be some visual artifacts. What can we do about this? Well, the best way to solve this is this. Instead of making a point here, we will make 2 points. So we create a flat surface where there is this pointy segment of the high-res. 2 points, and look what we have. Instead of a narrow angle, we have 2 pretty wide angles. Probably not square angles, but nonetheless, they're wide enough. It's better. This one is way better than this. This is exactly what we are going to do here. I'll apply edit poly modifier. Again, you can do it in any application. I'm just using a 3ds Max because it is my habit. I've been started modeling in 3ds Max almost 20 years ago. So I'm using it just because it's habitual. So I've selected the edge, and now I'm going to create a chamfer like this. I have created a chamfer. Hopefully I can see this. And in doing that, I have eliminated that narrow angle. But now I have 1, 2, 3, 4, 5 pointed polygon, and I cannot have that. It's not advisable. Therefore, I'm going to cut it. Kind of like this. Now I have 2 polygons. One is a triangle, and the same on the other side. And the other is a quad. These angle here along the edge of this this sort of blade. It is like 90 degrees or a little bit wider. It is okay. It will bake fine. I don't need a chamfer here. But how do I know that? Well, it comes purely from experience. I have, during my lifetime, during my career, I baked hundreds or perhaps even thousands of normal maps, and I just have a feeling for what will work and what will not work. And sometimes I'm wrong. In those instances, I just fix there. I do some test baking, and if something is not right, I will fix the geometry. Okay, another thing I would like to do, again, I don't have to do it here, because it will probably bake fine, but just it will probably also give a slightly better result if I do a chamfer here, something like that. It adds up to the density of the model, but it does not add that much. And by the way, another important thing is that you can actually you can add these chamfers before you do the baking, and afterwards, if you feel that you need to bring the poly count down, you can remove them. You can just collapse points like this, something like that, and the maps you have baked, they will still work, and the UV unwrapping will update automatically. Information in this lesson is sort of advanced stuff. It's not beginner stuff. I assume you have some experience with baking maps. I'm also careful. I'm making sure that I don't have 5-pointed polygons, because if I do, it will probably be converted on export into quads or triangles, but I just want to control it myself. If you are doing this retopology, the whole retopology inside Maya, let's say, it's easier for you because Maya allows you to create points and polygons on the surface of the model. At the same time, it has modeling tools, which Topogun does not have, to make these adjustments all inside one application. But I'm just using the pipeline I'm used to, because as long as you're using the tools which you are familiar with, and as long as you know what you want to achieve, it doesn't really matter what application you're using. By the way, I shouldn't really. I want to create a chamfer for all these parts which are sticking out of the cog, but I really should not select all of them at once. I should go one by one. So in case I make a mistake, I don't have to redo the selection for the entire group. Something like this. Again, here, as you can see, this operation resulted in some unwanted points. And I will take a target weld tool, which lets me do this so pretty quickly. Some of you might think that this is a waste of time, but if you really careful with your topology before you bake maps, you can get amazing results with just regular normal maps. And the goal here, of course, as always, is to preserve as much information as possible when you transition from high res to a low poly. And with this process, normal maps are crucial. And it is much more important to make sure that the edges of the model are modeled correctly. It's much more important than the cleanness of your topology. That really doesn't matter much. So it looks something like this. And if you remember how it looked in high res, the high res looked like this. So there are these sloped angles here. Anyway, I just didn't want to retopologize them by hand. Instead, I decided I'll do this chamfering inside 3ds Max, and along the way I will talk about the importance of edges. I will process the same way the rest of these elements, and then what I will do, I will bring it back into Topogun for some final adjustments.